Hello, my name is TTJ Kepsi Richard and welcome to my YouTube channel. Today, our discussion on discrete mathematics and relation for that matter will be on composite of relation. Before the video ends, we'll look at what a composite of relation means, how to find the composite relation, the composite of two relations, as well as how to find the power relation using the idea of composite relation. This will be a very interesting engagement, so please come along. So if R and S are two relations that's defined on a set, then the composite of R and S is written as S composite R. So we call this S composite R. And what does that mean? It means that you are going to match each and every element or each and every ordered pair in S against each and every ordered pair in R. If the first of the ordered pair, the first element of the ordered pair in S correspond with the second of the ordered pair in R, then the second ordered pair in R, or the first ordered pair in R will relate the second ordered pair in S. Let me take it again. You match each and every ordered pair in S against each and every ordered pair in R. If the first ordered pair in S correspond with the second ordered pair in R, then the first ordered pair in R will relate the second ordered pair in S. For instance, S contains the ordered pair 2, 1, and R contains the ordered pair, let's say 4, 2. So we are going to match 2, 1 against 4, 2. You see 2, 1, 4, 2. So the first ordered pair in S correspond with the second ordered pair in R. The 2 correspond with 2. Then the first ordered pair in R will relate the second ordered pair in S. So we have 4, 1 as one of the composite relation of S and R. I hope you get that. So now we'll take some sample questions and see how we can find the composite relations of two relations defined on a particular set. So let's look at our first example. Is it find the composite relation of R and S, where R is the relation defined on the set A equal to 1, 2, 3, 4 as R with the ordered pair 1, 1, 1, 4, 2, 3, 3, 1, and 3, 4. And S on the set B, which contain the numbers 0, 1, 2, 3, 4 as 1, 0, 2, 0, 3, 1, 3, 2, and 4, 1. We should find the composite relation R and S. So, how do we do that? The composite relation R and S will be written as S composite R. I hope I said that already. So, how do we find that? Our X composite R will be equal to. So, we take each and every ordered pair here in S and compare it with the ordered pairs in R. If the first element in the ordered pair correspond with the second of the element of the ordered pair in R, then the first element in R will relate the second in S. So that's what we are going to do. So we'll match them one by one. So the first one, 1, 0 against 1, 1. So you see that 1, 0, 1, 1 correspond with this 1, 1. So we have the ordered pair 1, 0. So 1, 0 is our first composite relation of S and R. The next one, 1, 0 against 1, 4. So you see that they did not relate, or they did not, the first here did not correspond with the second here. So it will not match. Then we take the second one, 1, 0 against 2, 3. You see that one too will not work. 1, 0 against 3, 1. So 1, 0 against 3, 1. You see that 1 will correspond with this one. Then we can have the relation 3, 0. So we have the ordered pair 3, 0. The next one, 1, 0 against 3, 4. So you see that it did not correspond, so we leave it as such. We take the second one, which is 2, 0. 2, 0 against 1, 1. There is no corresponding. 2 0 against 1 4. You can see there is no corresponding. 2 0 against 2 3. There is no such corresponding. 2 0 against 3 1. 2 0 against this 3 1. There is no such corresponding. 2 0 against 3 4. There is no such corresponding. So we leave it as such. Then we take 3 1. 3 1 against 1 1. You see that the first did not relate or did not correspond with the second. So we will not have such relations. Then 3 1 against 1 4. There is no such corresponding. 3 1 against 2 3. So you see that 3 correspond with this 3. Then we can have the relation 2 1. So we have the ordered pair 2 1 as one of the composite relations. 3 1 again against 3 1. This 3 1 against this 3 1. You see that there is no such corresponding. 3 1 against 3 4. This 3 1 against this 3 4. There is no such corresponding. So we are done with the 3 1. Then we take 3 2. 3 2 against 1 1. We can have such. 3 2 against 1 4. We can have such. 3 2 against 2 3. This 3 2 against 2 3. So you see that this 3 relate that 3. Then we can have the other pair 2 2. So we have the other pair 2 2. We are still on 3 2. 3 2 against 3 1. Against this 3 1. There is no such corresponding. 3 2 against 3 4. There is no such corresponding. So we are done with the 3 2. Then we take the last one 4 1. 4 1 against 1 1. We can have such corresponding. 4 1 against 1 4. 4 1 against 1 4. You see that the 4 relate this 4 or correspond with it. Then we can have the other pair 1 1. Still on 4 1. 4 1 against 2 3 now. 4 1 against this 2 3. We can have such corresponding. 4 1 against 3 1. This 4 against this 3 1. We can have such corresponding. Then a 4 1 against 3 4. You see that we will have such corresponding. And we'll have the other pair 3 1 as one of them. 3 1. Then we can say X composite R is the relation 1 0 3 0 2 1 2 2 2 1 1 and 3 1. I hope you get that. This is very simple. We'll take a second example and see how we'll go about it. So we'll look at the second question. Please, you can pause the video and solve it, try it, then you compare your answers with mine. They say the following relation R1 and R2 are defined on the set A equal to 1, 2, 3, 4 as follows. R1 equal to the set with the ordered pair 2, 1, 3, 1, 3, 2, 4, 1, 4, 2, and 4, 3. And R2 is the set with the relation or the relation with the set of ordered pairs 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, and 4, 4. We should find R2 composite R1. So how do we go about it? So you see that the R2 is first. So R2 will be written first. R2 composite R1. It means we match each and every other pair in R2 against the R1. If the first correspond with if the first in R2 correspond with the second in R1, then the second in R2 will relate the first in R2. The first in R1 will relate the second in R2. So that's it. So we are going to match them again. So we have R2 composite R1 will be equal to what? We take this first ordered pair 1 1 against 2 1. So we see that this first relate or correspond with that. Then the first here will relate the second. So we have the ordered pair 2 1 as first. We take the 1 1 again. 1 1 against 3 1. So 1 1 against 3 1. You realize that they correspond. So we have the ordered pair 3 1. The next one 1 1 1 1 against 3 2. So you see that there is no such corresponding. 1 1 again against 4 1. 1 1 against 4 1. You see that there is such corresponding. Then we have the other pair 4 1. 4 1. 1 1 again against 4 2. So you see there is no such corresponding. 1 1 against 4 3. There is no such corresponding. So we are done with 1 1. Then we take 2 1. 2 1 against 2 1. There is no such corresponding. 2 1 against 3 1. There is no such corresponding. 2 1 against 3 2. So look at it. The 2 correspond with these 2. Then we'll have the other pair 3 1. But the 3 1 is already there. So we are good to go. Then 2 1 against 4 1 now. 4 1. There is no such corresponding. 2 1 against 4 2. So you see that 2 will correspond with these 2. Then we have the relation 4 1. 4 1 is already there. So we are good to go. So 2 1 against 4 3 now. There is no such corresponding. So we ignore. Now we are done with 2 1. Now we take 2 2 and pair with all the other pairs in R1 again. 2 2 against 2 1. There is no such corresponding. 2 2 against 3 1. There is no such corresponding. 2 2 against 3 2. You see that the 2 correspond with these 2. Then we have the other pair 3 2. 3 2 2 now against 4 1. There is no such corresponding. 2 2 against 4 2. So you see that 2 correspond with these 2. Then we have the other pair 4 2. 4 2. Then 2 2 against 4 3. 2 2 against 4 3. There is no such corresponding, so we ignore. Now we are done with 2 2. We go for 3 1. 3 1 against 2 1. There is no such corresponding. 3 1 against 3 1. There is no such corresponding. 3 1 against 3 2. There is no such corresponding. 3 1 against 4 1. There is no such corresponding. 3 1 against 4 2. There is no such corresponding. 3 1 against 4 3. Look at it. 3 correspond with this 3. Then we have the relation with the other pair 4 1. But 4 1 is already there. So we are good to go. 3 1. So we are done with 3 1. 3 1 against 4 3 was the last one. Now we take 3 2. Almost there. 3 2 against 2 1. So we see that there is no such corresponding. 3 2 against 3 1. There is no such corresponding. 3 2 against 3 2. No such corresponding. 3 2 against 4 1. No such corresponding. 3 2 against 4 2. No such corresponding. Then 3 2 against 4 3. There is no such corresponding. Okay, 3 2 against 4 3. 3 correspond with 3. Then we have the other pair 4 2. That 4 2 is already there. So we are good to go. Now we take the next one, which is 3 3, and match it against already. 3 3 against 2 1. No such corresponding. 3 3 against 3 1. No such corresponding. 3 3 against 3 2. No such corresponding. 3 3 against 4 1. No such corresponding. 3 2 against 4 2. No such corresponding. 3 3 against 4 3. There is such corresponding. So we have the other pair 4 3. So we have 4 3. The next one, we take 4 1 and match it. 4 1 against 2 1. No such corresponding. 4 1 against 3 1. No such corresponding. 4 1 against 3 2. No such corresponding. 4 1 against 4 1. No such corresponding. 4 1 against 4 2. No such corresponding. Then 4 1 against 4 3 2. There is no such corresponding. So we are done with 4. We take 4 2. The last two. 4 2 against 2 1. No such corresponding. 4 2 against 3 1. no such corresponding. 4 2 against 3 2, no such corresponding. 4 2 against 4 1, no such corresponding. 4 2 against 4 2 itself, there is no such corresponding. Then 4 2 against 4 3, there is no such corresponding. Then we take the last one, which is 4 4, and match it. 4 4 against 2 1, you can see there will not be any such corresponding. If you see immediately that there will not be such corresponding, you just ignore for it to be faster. 4 4 against 3 1, there is no such corresponding. 4 4 against 3 2, no such corresponding. 4 4 against 4 1, no such corresponding. Please, the first here against the second there, so there is no such corresponding. 4 4 against 4 2, there is no such corresponding. Then 4 4 against 4 3, there is no such corresponding. Then we can say this is all the ordered pairs of the relation R2 composite R1. Please, I hope you get that. This is not anything difficult. The next thing we look at is power relations. So when we talk of power relations are relations. Let's say R is a relation, then the power relation is a relation in the form R exponent n, where n is equal to 1, 2, 3 in the order. So if n is 1, we have R exponent 1. R exponent 1 is the same as R generally. Then our R exponent 2, when n is 2, our R exponent 2 will be equal to R composite R. That's R exponent 1 times, let's say in indices, if this is multiplying, then 1 plus 1. Remember, when the bases are the same and they are multiplied, we add the exponent. Then what of R exponent 3? R exponent 3 will be equal to R exponent 2 composite R. And R exponent 4 will be equal to R exponent 3 composite R. I hope you get that. Then we can say our R exponent n plus 1 will be equal to R exponent n composite R. I hope you get that. Where n is the previous distance. So our R exponent n plus 1 will just be equal to R exponent n composite R. So this is very easy. Now we take some sample questions and see how you can combine the composite relation of a power relations. So let's look at a question on this. It says let R equal to the set with the ordered pair 1 1 2 1 3 2 4 3 be the relation defined on the set A equal to the members 1 2 3 4. We should find R exponent 2 and R exponent 3. So how do we do that? It's very easy. Remember, we said that when R is with the members, that's the set with the ordered pairs 1 1 2 1 3 2 and 4 3. So we say our R2 is equal to R composite R from the definition. So it means that we are going to match all the ordered pairs against each other if the first correspond with the second. Then the first in the second one will relate the second in the first one. So that's how we are going to do. So let's go. We take 1 1 against 1 1 itself. So you can see that 1 corresponds with this one. Then we can have the ordered pair 1 1. So we have 1 1. So we take 1 1 against 2 1. So you can see that 1 corresponds with this one. Then we can have the ordered pair 2 1. So we have 2 1. 1 1 now against 3 2. So you can see 1 did not correspond with the 2. So we ignore. 1 1 against 4 3. 1 did not correspond, so we ignore. Then that will do for 1 1. Then we take 2 1. 2 1 will compare with 1 1. You see that the 2 did not correspond with the 1, so we ignore. Then 2, 1 against 2, 1 itself. It doesn't, so we ignore. 2, 1 against 3, 2. Look at it. The 2 correspond with these 2. Then we'll have the other pair 3, 1. So we have the other pair 3, 1. Now, 2, 1 against 4, 3. So you see that they did not correspond. 2 did not correspond with the 3 here. So we ignore. The next one is 3, 2. 3, 2 against 1, 1. There is no corresponding. 3, 2 against 2, 1. There is no corresponding. 3, 2 against 3, 2 itself. There is no such corresponding. Then 3, 2 against 4, 3. Look at it. The 3 correspond with this 3. Then we have the other pair 4, 2. So the other pair 4, 2. Now we take the last one, which is 4, 3. 4, 3 against 1, 1. No corresponding. 4, 3 against 2, 1. No corresponding. 4, 3 against 3, 2. No corresponding. 4, 3 against 4, 3. There is no corresponding. Then we can say our R2 will be equal to the other pair 1, 1, 2, 1, 3, 1, and 4, 2. I hope you get that. The next one, which is R exponent 3, or R exponent 3, remember we equal to R exponent 2 composite R. So what does that mean? We match all the other pairs in R exponent 2 against all the other pairs in R. If the first in R exponent 2 correspond with the second in R exponent 1, then the first in R exponent 1 will relate the second in R exponent 2. So we are going to do it for that too. So the first one, we'll pick 1, 1 against this 1, 1. So remember, this is R exponent 2 against the R. So 1, 1 against 1, 1. You see that there is corresponding. So we'll have the other pair 1, 1. The next one, 1, 1. Again, this 1, 1 again against 2, 1. There is corresponding. So we'll have the other pair 2, 1. 1, 1 again against 3, 2. This 1, 1 against this 3, 2. There is no corresponding. So we ignore 1, 1 against 4, 3. You can see there is no corresponding, so we ignore. Then we take the next one, which is 2, 1. 2, 1 against 1, 1. There is no corresponding. 2, 1 against this 2, 1. There is no corresponding. 2, 1 against 3, 2. 2, 1 against 3, 2. So this 2, 1 against this 3, 2. You can see that the 2 correspond with these 2. So we have the other pair 3, 1. Then the 2, 1 against 4, 3. Against 4, 3. There is no such corresponding. So we are done with the 2, 1. Then we pick 3, 1. 3, 1 against 1, 1. There is no corresponding. 3, 1 against 2, 1. There is no corresponding. 3, 1 against 3, 2. No corresponding. 3, 1 against 4, 3. Look at it. The 3 correspond with these 3. Then we have the other pair 4, 1. We have the other pair 4, 1. The next one is 4, 2. So 4, 2 against 1, 1. There is no corresponding. 4, 2 against 2, 1. This 4, 2 against 2, 1. There is no corresponding. 4, 2 against 3, 2. No corresponding. 4, 2 against 4, 3. No corresponding. Then we can say this is the relation. So our R3 is a relation with the other pair 1, 1, 2, 1, 3, 1, and 4, 1. So we'll end it here today. Please remember to subscribe to my YouTube channel. This will make my YouTube channel grow more. and I can record more of these videos for you. Until we meet again, my name is TTG Kepsi Richard.